Hi, my name is Karen Benga. My project is over the chemical processes. Um, the nitrogen gas and hydrogen gas along with inert gas are fed to a reactor which then cools the mixture into ammonia. The purpose of my project was to maximize the amount of ammonia produced while minimizing what's going into the feed. So for the code, the user enters the mole fraction right here, along with the fraction conversion of reactor, which is FSP, and the fraction of gas that's leaving the condenser, which is YP. So these will be our givens, and based off of those, I've calculated the NR, which is the total moles fed to the reactor, along with NP, moles of ammonia produced, and the FOV, which is a fraction of overall nitrogen conversion. Based on these variables that were given, we were able to come up with these equations that we put into our function, which is just NR is equal to 1 minus X initial naught over the FSP plus YP minus YP times by FSP minus all that from X initial naught divided by YP as well. That will give us the moles that were fed to the reactor. Moles of ammonia produced will be given by 1 minus X initial naught, divide that by 2 times the addition of FSP and YP, subtract that from YP times the FSP. And the overall conversion would be given to us by 4 times NP, 4 times this, divided by 1 minus X initial naught. These are the equations I came up with by using the inputs. Alright, so for my second task, we graphed the 3 given variables separately while keeping 2 of them constant, one of them making them a dependent variable, also making a range for them as well, and graphing them against the amount of ammonia produced, which was the NP. We did that 3 times. The first graph was YP versus NP, the second graph was FSP versus NP, the third graph was X initial naught versus NP, and for all 3 of them, the X variable, which is an independent variable, all 3 of them had a range of numbers that it was gonna take and plot, like right here. And as X initial naught was from 0 to 0.999, and we graphed those. For this third task, the previous graphs were not enough to determine where to optimize, so we graphed the 3 given variables against each other. So we made X initial naught the independent variable, and FSP and YP the dependent variable, and graphed those. And where those 2 graphs met was where we maximize the production of ammonia. So for the fourth task, the purpose of our task was to find out the cost of cooling the gases and making ammonia. We figured that out by determining the enthalpy of nitrogen gas, hydrogen gas, inert gas, and ammonia, and multiplied that by the cost of making 1 megajoules. This is the equations to figure out the moles that were used for each of them, and these are the equations to find out the enthalpy. After finding out the enthalpy or the heat, and then we just added them together to find the total heat that was coming off, and we multiply that by the cost of making 1 megajoule. And that's how we determine the cost of making ammonia. So to run my code, I'll run it. It'll ask me to enter the mole fraction of inert gas. I'll enter 0.04. Fraction conversion of reactor, 0.20. Fraction of gas leaving the condenser, 0.1. And then it'll show me the moles of moles that were fed to the reactor is this much, and then the moles of ammonia produced this much, and the overall fraction is this. And then for tax 2, it was the 3 graphing problems. I graphed my first graph, figure 1, which was YP versus NP, FSP versus NP, and X initial naught versus NP. And since that wasn't enough to determine which one to optimize, I graphed this one, which was X initial naught versus FSP and YP. The blue one is the FSP, and the red one is the YP. And where they meet is where you maximize the amount of ammonia produced. And so X initial naught is what we chose to maximize. All right, closing this out and then running the second script. And also this is, I just printed what maximize and what we minimize. So it just says after graphing moles of ammonia produced versus what's going in, we decided to maximize moles of inert gas going in and minimize fractional conversion of the reactor, since the graph of X initial naught versus FSP decreases. And to run this while loop, it'll ask us to enter a mole fraction again, and I'll just enter the same numbers that I entered previously, except this time it'll just have a different number for the molar inlet, and it did say on the rubric for it to be less than 1, so I'll keep it 0.9. And so the overall cost of cooling was 10 cents per hour. And it's just asking me if I wish to repeat, meaning if you enter more numbers, and this while loop can be used in the future as well, as to determine how much it will cost depending on what you put in and what will come out. It'll tell you that, and it's just once you click no, it'll just stop.